Hi friends, in this lecture we will discuss about kinetics of particles 1, that is D'Alembert's principle. This D'Alembert's principle basically we will get from Newton's law. Now if we take any block of say mass m, this here, say this one is one block which one is at rest on say horizontal plane. A block is at rest initially. If we draw free body diagram, mass of block is m kg, weight of block acts in downward direction, so weight of block becomes m into acceleration due to gravity. Here we will get at contact surface reaction, which one is normal to the contact surface, so what we will get here, Rn. Suppose this block is subjected to some external force F, and assuming contact surface, smooth contact surfaces, therefore frictional force is 0. Newton's law, you know, when any resultant force acts on a body F, that is equal to mass into acceleration. What it represents, whenever any body is subjected to resultant force on a body of some mass m kg, then body accelerates with a meter per second square in the direction of resultant force. That means if we relate this equation to this FBD what you have drawn, force F is resultant force, there is no other horizontal force acting, because what you have taken frictional force as 0. Assumption is smooth contact surfaces. Therefore F represents what? Resultant force acting in horizontal direction. Mass of block is m kg. That means this block accelerates with this acceleration a in this direction, in the direction of resultant force. That means as per Newton's law, whenever any body is subjected to resultant force, then that body of mass m kg accelerates in the direction of resultant force. In this case, motion is in horizontal direction. Motion in inclined direction is also possible. Motion in vertical direction also possible, depending on direction of resultant force. Now if there is a single force F, I have taken this as a resultant force F. If there are number of forces, maybe mu is given, you will get frictional force in leftward direction. Therefore this F is resultant force, may be written as a summation of F equal to mass into acceleration, where this summation of force means what? Resultant. This is also what? Resultant force. That means resultant force R equal to what? F equal to what? ma. If number of forces are there, we will find out the resultant applying our equation, and with proper sign convention, rightward may be positive or upward positive depending on direction of motion. What we have written here, this is nothing but what? Your basic Newton's law, or particularly Newton's second law, F equal to mass into acceleration. Now unit of force is Newton, unit of mass is what? Kg, acceleration is in meter per second square. That means on the right hand side, what unit of this ma will get is nothing but what? Kg into meters per second square is unit of acceleration, which is nothing but Newton. That means ma term what we are getting on the right hand side is also force. Now this force you will get whenever there is a acceleration a. If body doesn't accelerate, that means resultant force is 0. You can say problem of static equilibrium, acceleration 0, what you will get? Equation of equilibrium as summation of forces, means resultant force as 0 when body is in equilibrium. Now body accelerates with this acceleration a, so this summation of all forces is equal to mass into acceleration. What it represents, whatever the resultant force acts on a body is equal to this force which is m into a, where this ma is also force, summation of forces also forces, means resultant force. If I will take this ma term on left side, So because this one is a force, therefore all forces will write on one side of equal sign, say on left side of equal sign. So can you say this is summation of forces plus, now ma term with minus sign we have to take because it is acting in leftward direction, equal to 0. That means as summation of all the forces including this ma with negative sign I written here equal to 0. That means summation of all forces acting on a body is what? 0. Now this ma force, mass into acceleration, is called as inertia force, and negative sign represents what? This force always opposes the motion and acts in opposite direction of acceleration. This one equation which includes now inertia force on same side, right? This depends on what is the direction of motion. That means if body accelerates in horizontal direction, this one may be written as what? Summation of forces along x-axis plus this one minus mass into acceleration along x-axis equal to 0, or this one along y-axis if body accelerates, to summation of forces along y-axis plus then this one is minus m. If resultant force is in vertical direction, body may accelerate along y-axis, to minus m into ay equal to 0. Similar equation is possible for curvilinear motion also, because in curvilinear motion whenever body accelerates having some mass m, in curvilinear motion you will get resultant acceleration which is resultant of normal component of acceleration and tangential component of acceleration. As in rectilinear motion you are applying equation along x and y axis, then this may be written as what? For curvilinear motion along, you can say tangent. In curved path, if you draw a line which just touches the curved path is called as tangent. What are the forces acting along tangent? Plus now what will get? Inertia force, which one is acting along tangent is what? Minus m into at. Or if we'll apply similar equation along normal, again what will get here? Minus mass into an equal to what? 0. That means now I written all mass into acceleration, this term on left side. Why all are negative? Because inertia force always acts in opposite direction of acceleration. That means now this ma force, which one is one of the force acting on a body, this one acts on a body when your body is subjected to acceleration. In free body diagram, if I'll add in opposite direction of acceleration, so this force becomes mass into acceleration, ma. That means now if you want to apply equation, what will do? Can you write summation of all forces along x-axis 0? That means f minus ma equal to 0. That means f equal to ma. Basically what you are getting Newton's law. But when we will write f equal to m into a term on right hand side, then it is called as Newton's law. If we will write ma term on left side, then same equation is called as what? This one is called as D'Alembert's principle. This one is as per D'Alembert's principle. That means basically simply term ma is important, right? D'Alembert's principle. What is the difference in Newton's law and D'Alembert's principle? It seems to be same, but only difference is what? When you write f equal to ma, it is Newton's law. Now if you take ma term on left side, then that summation of forces plus minus ma is what? D'Alembert's principle. But while solving problem, applying Newton's law as well as D'Alembert's principle, same solution is possible. But difference is what? Basically in Newton's law you have to represent free body diagram twice, where first one is for deciding this force or summation of forces, one free body diagram of block equal to, will represent equivalent force diagram in which we will get only ma force. But now if I take ma force on left side minus term, you can represent it in FBD in opposite direction of acceleration. Therefore in D'Alembert's principle, using single free body diagram, solution is possible. Unknown terms may be acceleration or maybe some unknown force. Now in free body diagram, if we'll add inertia force in opposite direction of acceleration, then the principle is called as D'Alembert's principle. Now as MA is nothing but a force and this one is also force, that means addition of all forces and inertia force equal to 0. That means can we say summation of all forces equal to 0 along x-axis, summation of all forces along y-axis equal to 0, summation of all forces along tangent equal to 0, because MA force we are representing in free body diagram now. So if we will write again equations equal to 0 0 0, that means these are equations of equilibrium, but body is in motion, that means body accelerates, and when we will add this free body in if we will add this inertia force in free body diagram, then in FBD what force we are getting MA, that inertia force and all other forces must get balanced. Body is in motion but body is in equilibrium. Therefore same equation where we will write summation of fx, fy, ft and fn equal to 0, all such equations are called as equations of dynamic equilibrium. That means how we will write equations of dynamic equilibrium? See next page. Equations of dynamic equilibrium. Now in equation of dynamic equilibrium, they are similar to that of equations of static equilibrium. Difference is what? Which includes inertia forces. That means summation of fx equal to 0, summation of fy equal to 0, summation of forces along tangent equal to 0, and summation of all forces along normal equal to 0. But all these equations, this includes what? Including inertia forces. So that MA term will not write in equation, but will add this term where? In free body diagram. Therefore simply as we are applying equation in static, similar equation will apply. Difference is only what? Inertia force comes into picture, will represent in free body diagram in opposite direction of acceleration. Using this one, these equations all consist of what? Number one, number of forces, then acceleration term, that means forces and acceleration. Unknown, maybe you can say acceleration, all other forces are given, find out acceleration of body, or acceleration may be given out of 3, 4, 5 forces which are acting, one of the force is unknown, find out magnitude of such a force, one of the unknown force, so that body is subjected to so and so acceleration. Such type of problems are possible. That means what are the steps to solve the problem? You can say number one, we will draw free body diagram of given body. Once we will draw free body diagram, in that one which includes what? Any external force which is acting, weights of the bodies, normal reaction. Then from magnitude and direction of forces we will decide resultant force acts in which direction. The resultant force acts in some direction, the acceleration of block must be in same direction as per Newton's law. We will represent that direction of acceleration by dotted line because it's not a force. Then in opposite direction of acceleration we will represent what? Inertia force. Once we will represent inertia force, we will apply equations of dynamic equilibrium. Maybe acceleration along x-axis, so it becomes summation of fx equal to 0. But if in y direction there is no acceleration, so summation of fy equation what will get is similar to that of equation of static equilibrium. Now single body problem is given, then it becomes easy. But if number of bodies are connected by cables or by string, then you must know in this case how to find out relation between acceleration of connected bodies. So just see, we will discuss this one just on next page. Just see here. Relation between acceleration of connected bodies. Say this is number one. Now I'll represent here some two blocks. Just concentrate how bodies are connected to each other. Say this one is one block A. This block is connected by means of a cable. wire and it is passing over one pulley where pulley is supported here like this. Same cable is connected to different block. Say this one is what? Block B. This block is what? A. Now if we'll represent forces, so definitely weight of this block B acts in downward direction. That means what we'll get here? Mass of block B into G. What we'll get here? Mass of block A into G. Actually motion of block A is possible in a horizontal direction and motion of block B is possible in vertical direction. As weight of block B is acting in vertically downward direction and due to MA or weight of block A will not get any force in this string because this is vertical and string is horizontal. What tension is developed in the string is due to weight of this block B. Therefore in this case block B has to accelerate in downward direction. That means this is acceleration of block B. If block B moves or accelerates in downward direction, block A has to accelerate in rightward direction. Say this is what acceleration of block A. Now what you have to decide, what about AA and AB? They are same or they are different? Simple. They are connected by single string passing over this pulley where when actual motion starts, the center of this pulley doesn't translate in any direction. This pulley simply rotates about this point. And if this pulley is, you can say it is frictionless, if pulley is frictionless, then what tension is developed in this string on both the side is what? Same tension is developed. When your pulley is frictionless on both the side of a pulley, you will get same tension gets transferred on another side of pulley. And center of pulley doesn't move in any direction, therefore such pulley is called as what? Immovable pulley. It is called as immovable pulley. Therefore what pulley you are getting here is frictionless and immovable pulley. When your pulley is immovable, then now in this case if you assume block A moves by 1 meter rightward, it is connected by single string, block B has to move by what? Same 1 meter. That means displacement of both the blocks are same. Their velocities are also same and their accelerations also same. That means when you can say velocity, displacement and acceleration of connected bodies are same if two bodies are connected by string passing over immovable pulley, then their displacement, velocity and acceleration remain same. That means in short, for this case, I will conclude, if bodies are connected by string or cable passing over immovable pulley, then displacement, acceleration and velocities are same. That means for these blocks, can you write here like this? XA equal to what? XB, that means displacement same. Velocity of block A equal to velocity of block B, and acceleration of block A equal to acceleration of block B. That means whenever any number of bodies they are connected by cable or string passing over immovable pulleys, then their displacement, velocity and acceleration remain same. This one is a case 1, you can say, right? You may get such a situation where bodies are connected by cable passing over movable pulleys. See on next page, I'll represent pulleys whose center moves in some direction. See on next page, when bodies are connected by a string passing over movable pulleys. Now here, say this one is number 2. One block, say block A is resting on horizontal plane. Now this block A is connected by cable which is passing over this frictionless pulley, and center of this pulley is supported to this, you can say, horizontal plane here. That means this pulley, once it is supported by, you can say, hinge or pin connection, that means this pulley becomes immovable pulley. Now one cable is passing over this pulley, but how it is connected to other block, I will represent here. There is, you can say, one more pulley here, and that string is passing over same pulley, and vertically it is supported to some reference ceiling. Now to the center of this pulley, one more block is connected here. Say this one is what? This one is block B. Now in this case, this pulley what I represented here, its center doesn't move in any direction. That means this pulley is again immovable pulley. This is immovable pulley. But what other pulley you are getting? Say name of this pulley is C. Center of this pulley definitely moves in upward or in downward direction. Due to weight of block B, say block B moves in downward direction, center of pulley also moves in downward direction. That means such pulley is called as now movable pulley. This pulley is called as movable pulley. Whenever any number of bodies are connected by a cable passing over movable pulley, then displacement, velocity and accelerations of connected bodies are not same. Now how will get this relation between, you can say, displacement, velocity and acceleration? Simple. First one, say due to weight of block B, this block moves in downward direction by, say, displacement dx. xb is a displacement of block B. This block A, you will get some displacement in rightward direction. As xa and xb, these are displacements of the blocks. Next step what we'll do, if I'll assume here what tension is developed in the string is, say, T. Pulley is frictionless, therefore same tension gets transferred on this side. Again pulley is frictionless, that means same tension gets transferred on the right hand side. Now to balance this T and T which are acting on pulley C in upward direction, here in this cable joining pulley C and block B, what tension must be developed here? So T and T upward, to balance this twice T force must be developed in this cable. That means what tensions are developed now, they are different connecting block A and B. For block A, if I'll cut it like this, that means now separately you concentrate on block A and block B. On block A, what tension is acting is T rightward. On block B, what tension is developed is what? Twice T. These T, twice T, or any number of tensions which are developed in the string, all these are called as internal forces developed. Where motion is possible of blocks A and B is not due to tension, it is due to what? Particularly due to weight of this block B. That means active force what is here is nothing but weight of block B. Motion is not possible due to tension, but what tensions are developed, they are due to masses of the blocks. Therefore you can say work done by such internal forces, means tension, is always zero, because work is not done by internal forces. Internal forces are developed due to external forces or weights. That means here what tensions are developed, these are internal forces developed due to weights of the bodies. Therefore here work done by internal forces is always zero. Work done by internal forces, that means here what? Tensions is zero. As you know, work done by internal forces is zero, that means here work done by this internal forces is zero. Now identify where internal forces are acting, what are the displacement, and from that on we will try to find out work done, and then we will equate that work done to zero. So on block A, what internal force is acting is rightward, displacement of block also rightward. Now you know when direction of force and displacement are same, work done is positive. That means work done by this tension, if you find out, it is, you can say, T into what? Exa, and this is positive work done. For block B, displacement is in downward direction, but tensions are acting in upward direction. Direction of force and displacement are opposite. Work done by twice T is what? Negative. Displacement is what? XB. That means what? Equal to 0. There is no other, you can say, internal force or work done by any other internal force. Now, therefore, what will get here? XA into T equal to XB into what? Twice T. Now T term gets cancelled, so what will get here? XA equal to what? 2 times XB. In short, what you are getting? Relation between displacement. That means to find out relation between these displacement, what we have to do? Work done by internal forces equal to 0. And which one directly also it is possible, we will discuss later on. Now, as this is the relation between a position or a displacement, if we differentiate once with respect to time t, dxa by dt is nothing but velocity of block A, dxb upon dt is what? Velocity of block B. That means what? The next equation will get velocity of block A equal to 2 times velocity of block B. Again, if we differentiate once velocity with respect to time, what will get? Acceleration of block A equal to acceleration of block B. Now, just by observing a system of bodies, connected bodies, how will identify this relation? Simple. See how many tensions are acting on block A, how many tensions are acting on block B. On block A, tension acting is only 1. Therefore, 1 into XA or 1 into VA or 1 into AA equal to, on block B, 2 times tension are acting. That means what will you can say? 2 into XB or 2 into VB or 2 into AB. That means relation becomes what? 1 into XA equal to 2 into XB, 1 into VA equal to 2 into VB, 1 into AA equal to 2 into AB. Direct relation is possible. That means work done by internal forces is what? 0. Using this one we will get such relation. Just count number of tensions acting on a body. For example, what we'll do, one more you can say system of connected bodies I'll represent, and from that on again we will get idea how we will get a relation between displacement, velocity and acceleration of the bodies. Now just here, say this one is what? Horizontal plane. Now I will represent here some 2 different bodies which are connected by cable or string. Now here say this one is one block, say block A, and this one is nothing but block B. Now these 2 bodies are connected. How they are connected? Number 1, here there may be one horizontal cable and this one is a pulley. One string is connected to this block, then the string is passing over this pulley. There is one more you can say pulley, frictionless pulley, and this one is some rigid support. Center of this pulley is connected to this block. Say this is block A, this is block B. Can you identify what is relation between this? Displacement, velocity or acceleration. Assume say this block is subjected to some external force P. That means block A, its displacement XA leftward, and this displacement is what? XB is what? Leftward. How many tensions are acting? That one if you want to decide. This one is a continuous string. If you assume here tension develop is what? T. Same string is passing over this pulley, therefore on another side same tension. Again what will get here? Same tension is developed here. Continuous string. That means here what tension is developed to balance T and T is what? Twice T. T and T acting in leftward direction. That means on pulley tension must be developed is what? Twice T. Here also same thing, T and T what is acting here is twice T addition. That means here what tension is developed is twice T. On block A total number of tensions acting are how much? To twice T. And on block B total number of tensions acting are twice T plus T. That means relation between displacement is what? How many tensions are acting on block A? 2 times. On block A, tension acting is twice T, therefore 2 times XA equal to, on block B, how many tensions are acting? 3 tension, therefore 3 times XB. That means you can say XA equal to 3 by 2 XB. One relation. Same relation for velocity, 2 times VA equal to what? 3 times VB. That means VA is written as what? 3 by 2 VB and 2 times acceleration of block A equal to 3 times acceleration of block B. That means AA equal to what? 3 by 2 AB. That means simply you have to concentrate on how many tensions are developed in the string, and easily we will get what? Relation between acceleration of connected body. First thing what we have done, when any string is passing over the pulleys and connected to given blocks or bodies, and that pulley is immovable, then their displacement, velocity and acceleration remain same. But if a string is passing over movable pulley, then we will find out relation between acceleration as just now we discussed. Thank you.